Hey guys, Tom Griffin with National Flooring Equipment. Thank you for watching. We are going to be going over our A97 Shot Blaster and our DL4000P Dust Collector. So this machine pairing is pretty simple to set up. The Shot Blaster uses steel beads to blast the concrete, and it's paired with this auto-pulsing dust collector so that you're able to continually work without having to stop to pause and clean the filters. So the first setup is going to be to run power to the dust collector or directly to the Shot Blaster if you're not using the DL4000P. Then you're going to connect power from the dust collector to the Shot Blaster. Just as a heads up, we do have a special plug that is required to plug the Shot Blaster into the DL4000P. We're going to do a different video a little more in depth on what's required out of that, but if you're not sure if you have the correct plug, just reach out to National. We'll confirm that you have it, or if not, we can give you the part number and get you the part. And then after you've got power as well, you want to connect the hose. We do have a cable and hose management system built into the Shot Blaster. So the hose would come out of the dust collector and it would plug in right here on the Shot Blaster, and you can cinch this down and that'll keep the hose and the cord in place. To fill the shot in the Shot Blaster, you're gonna open up this hopper and you're gonna pour shot. When you're looking down in here, you can see it, there's a screen that takes any metal or debris that gets picked up when the machine's running and filters that out, allowing the shots to fall through. And you're just gonna fill this hopper up to the bottom of that screen. And the reason you're not gonna fill it all the way up is these machines work on rebound and suction. So part of that is when the shot gets recycled through the machine, there's a cleaning area, air wash system in here where the vacuum, the suction, is actually pulling all of the dust that's going through the machine out to the dust collector, and it allows the shot to fall back through. So if you fill it up too much, you're actually going to impede that process and the machine's going to start dropping shot on you. So this is where you fill the shot. And you also want to make sure to charge the magnets before you start running the machine. And you do that by pouring a little pile of shot down here on the floor and running the machine back and forth over it. Charging the shot just basically builds a curtain of shot on those magnets underneath the machine. That's a safety thing. It keeps the shot from flinging out of the machine and all over the job site, which would create a slip hazard. And then what you'll do is back the machine up once you've charged it, use a hand magnet or a sweeper magnet to pick up all of that shot. Again, this works on rebound and suction. So if you have a pile of shot underneath the machine, you turn it on, that shot hits the other pile of shot on the ground and it can't rebound. So you're gonna lose your shot there and then you're gonna drop shot on the ground. So just clean that up first. Another thing you wanna make sure you do is put the drive pin into the machine. So something we get a lot is you can turn the machine on, the drive motor is spinning, but the machine doesn't go anywhere. So you do have to put a drive pin in the machine. We have a little storage hole right here for it. And what I like to do is turn the speed way down on the machine to like a 1. And then any of the 3 holes on the side here, you can actually push the pin through and lock it into the drive chain. Once you've done all that, as long as you've checked and made sure that the blast wheel is spinning in the correct direction, which is counterclockwise, then you're good to go. If the blast motor is spinning in the wrong direction, there is actually a phase inverter here where you can use a screwdriver and you just turn 2 of the pins. You don't have to go back to the box and rewire anything. The machine can handle that itself. This is a really ergonomic, easy to use handle, but you do have to make sure it's set at the right height. This is actually a little short even for me. So you've got a couple ways you can adjust it here. So loosen this pin. I'm gonna put it up a notch. You kind of want your arm at a 90-degree angle, whatever's comfortable for the operator. And then if you, let's say you want it a little bit more angled, you can also adjust it here so you can angle it however you want. Again, everybody's different, but this allows everybody to customize the machine to make it comfortable for a long day's work. The controls on this machine are pretty straightforward. On the joystick, you have a trigger button. This is to go forwards, which actually means you're walking backwards. The trigger plus the blue button is going to be reverse, which pushes the machine forwards. And then there's a gray button as well. Trigger plus gray is overdrive. So when you get to the end of your run, you want to turn around as quickly as possible, so you don't want to have to speed up and slow down every single time. So you just push the overdrive, it overrides the speed control and gives you full speed to turn around. When you let go, it returns to the speed that's down here on the speed control. Your speed control is also located here. It's very easy to adjust as you're moving if you need to change your profile. On the control panel, you have your main power, which is the main power to the whole machine. When you turn this on, you should see your controls power turn on. This tells you do have power. Your amp meter should light up and display a small number. There shouldn't be anything larger than 0.1. You have your hour meter, which is great for watching maintenance. As we talk about in the video, every 40 hours or so, changing out your blast wheel. When you turn your blast motor on, this light will turn on, just a visual indicator to show you that power is being supplied to that motor. So when you turn it on, the light will turn on. When you turn it off, the light should turn off. Then obviously, if something's going wrong, the machine's malfunctioning, you have emergency stop there, which kills power to all the motors. So to turn on your dust collector, you want to turn on your main power. When you do that, your power indicator light will turn on, your green light should turn on. It may not start to compress until you have the actual vacuum motors on, but if this does not light up for some reason, then you know something is wrong with the compressor and you should reset it. If you are looking to do 3-phase power out, you want to make sure it is to socket 1, and socket 1 is on this side. If you want single phase power out, you'll switch to socket 2, and that is on this side of the control box. If you see this yellow light on for any reason, please refer to your instruction manual or call an FE for troubleshooting help. When plugging the machine into the DL4000P, whether on the single phase or the 3-phase side, you want to make sure that the plug is in fully and securely, because in order to supply power to the machine, you have to have your plug selected correctly. You also have to be able to turn this on. As you can see, my plug isn't in completely because I'm locked out from turning that. So I'm going to make sure that it's on, and it locks the plug in and allows power to the plug itself. When you are done to unplug the machine, switch it back to off, and you can pull it out. So once you're all ready to go, you want to make sure that you turn your dust collector on. First, it's going to be all 3 switches, and you want to give it a moment. There is a compressor on this machine. You want to make sure you hear that compressor charge up and discharge. Once you've heard that, you know that the auto pulse feature is working and this is ready to go. The next thing you're going to do is turn on your main power to the machine here. It's going to light up, and then it'll tell you you've got control power. You can test your drive motor to make sure that that's working, and then you want to turn on your blast wheel. So you want to leave your blast wheel off until you're ready to blast. So even if this valve's closed all the way, just a caution that even 1 or 2 little pieces of shot rotating through that system, if the machine sits in one place, can actually dig a trench over time or leave a mar in the concrete. So once you're ready to go, that's when you turn this on. You'll start walking backwards with the machine. You're not gonna slam the valve open. You wanna just open it nice and gently. That'll allow the shot to start flowing. It won't create a power surge and cause the machine to drop shot. When you get to the end of your run, it's important to close the valve and then make your turnaround. So these machines are designed to work in a mostly straight line. So we've had some questions in the past about blasting in a curve, and what that'll actually do is cause the rebound to mess up and you'll start to drop shot as you go. It is natural sometimes to see some shot left behind. So as you go over the concrete, it's not flat. You have the ability to raise and lower this. If you've got humps in a slab of concrete, you might leave some shot behind. Little bits here and there is okay. If you start to notice a very big trail behind the machine, you should turn it off and troubleshoot. It's important when you start out to be as close to the dust collector as you can and to work away and then back to the dust collector in a zigzag pattern. Working in that zigzag pattern will allow you to have the most efficient use of the hose and the cable without tangling them up, and it allows anybody else around to do other tasks rather than have to mind that hose and cable for you. Shot blasters are designed to work in one direction. So this machine is designed to work with the operator walking backwards. If you try to run the machine while the operator is walking forwards, what this is going to do is cause the shot to pile up inside. You're going to lose that rebound and you're going to start dropping shot. There are machines on the market that are designed to work the other way, but this machine is designed for the operator to always be walking backwards. And the reason that we have the operator walking backwards is your shoes are dirty. You're profiling this beautiful floor and spending all of this time getting these pores open and the concrete clean, ready for its next coating. If you were to be walking on that surface, you're going to be getting dirt and oil and other things from the bottom of your shoes. So by walking backwards, you actually aren't going to set foot on that beautifully profiled floor. It's going to keep it nice and clean and ready for whatever the next coating is. Earlier in the video, I talked about why this is a great machine for doing edge work. In order to do that, you take this magnet off, and this plate is going to install. There's a little slot right here, and it's going to sit here. You want to tighten the plate down, but you don't want it so tight that it's stuck to the machine. You want it to be able to float up and down as you go. So the machine is designed with these brushes around the edge and the shot underneath to allow airflow into this chamber to help suck the shot up as you're doing the shot blasting. And when you replace this side magnet with this plate, you cut off a good bit of the suction. So this is great for doing your edge work, but you don't want to leave that on all of the time because the machine will actually function better and more efficiently with that brush installed. So one of the first questions that I always get asked when I go to a job site is, how do you get this CSP, whether it's a 2, 3, or a 5? And I always have to tell guys, it's a combination of two things. It's a combination of how many amps you're drawing. The amps are a measure of how hard the machine is working, how much shot is flowing through the machine, and your speed, how fast you're walking backwards. So I can hit really hard and walk really fast and get a brush pass, or I can make the machine work really lightly and go really slow and achieve the same thing. So it's a balance of how many amps you're pulling, how hard the machine is working, and the speed you're going. So what I always kind of tell people is, the best thing to do is to figure out how comfortable you are walking backwards. Are you great at it or not? So if you're not, maybe you go a little bit slower and you have the machine work a little bit less. If you are a sprinter and you want to fly backwards, then crank that speed up and you can let the machine work a little bit less. But it's really important to find that balance. So one of the great things about this machine is that it is self-propelled. So with our A95, our small manual walk behind, my gait is different than somebody else's gait. My steps maybe are a little bit shorter than somebody else's, and that leads to inconsistencies in the blast pattern. With the self-propelled machine, if you've tested your concrete and it's all pretty much the same hardness throughout the job, then if you know the machine is pulling 24 amps and you're at a speed 5, for instance, then it doesn't matter who's operating it. It could be me, it could be someone else, but as long as the machine's pulling 24 amps and you're at a speed 5, and the concrete is the same hardness, then you're gonna get an even profile throughout the job site. So it takes one of those inconsistencies out of the process. So if you want to adjust either of those, there's two ways to do it. Your speed control is right here on the handle. It's really easy, just turns one way or the other, goes faster or slower. That's where the overdrive comes in. So if you know that you like the speed 5, then rather than having to speed up at the end of every single run and then put it back down, you might miss it or do something wrong. If you always leave it at 5 and use that overdrive, then it puts the machine up to full speed. You can make a quick turn. As soon as you release that overdrive, it slows back down to the speed. It slows back down to the speed here on the control. The other adjustment you can make is to the amount of shot flowing through the machine. So this handle pulls on a cable. It opens a butterfly valve, a lot like a carburetor on a car. And the more that valve opens, the more shot flows through the machine. The more shot, the more power you draw. So this machine's happy place is somewhere between 24 to 27 amps. If you're anything lower than that, you might run into some issues where you're gonna start dropping shot, or you're gonna notice very slow or low production. So you can adjust it. There's a bolt here. If you push the bolt in, it limits how far that valve can open, so you'll have less shot flowing through. If you pull the bolt out, it's gonna allow that valve to open more, and you're gonna have more shot flowing through. Again, the amp draw here is based on how much shot is flowing through the system. You might run into a power situation. This is designed to work on 30 amps. But let's say for some reason you're approaching that 30 amps and you're popping the breaker continually, then you can actually adjust your shot flow down so that you don't pull that many amps. You can limit it so you're not gonna pop that breaker. So this machine is designed to give a nice even profile across the full width of the blast. After transport or changing out your control cage or shipping the machine, you might notice the blast pattern's off. Just look at which side is heavier and adjust your control cage by tapping it in the direction of the heavier blast. So general maintenance on these machines, the things you want to keep your eye on are your blast wheel. They're good for roughly 40 hours, but depending on how much silica is in the concrete or what you've been blasting, you might get less hours or you might get more out of it. So what's really important is you can either take it out from the top here, or you can tilt the machine over, shine a light up underneath the machine and look at the actual blast wheel. So you'll notice there's paddles on this machine, there's 4. And what you're looking for is, as this machine blasts, it's gonna dig troughs into that blast wheel. If any of those troughs is approaching 3/4 of the way through that paddle, it's time to replace the blast wheel. What'll happen if you go too far beyond that 3/4 mark is the blast wheel could shear apart. It's gonna throw shrapnel down onto the concrete, it's gonna get sucked up into the machine, and then you really have to spend a lot of time cleaning out this machine and making sure that everything is good to go. It's also kind of scary for the operator, so you really just wanna make sure you watch that. You also have liners inside. So this is the steel body. There's another panel on the inside that's designed to wear away over time. It protects the actual body of the machine. Typically, you're gonna go through, 2, 3, 4 blast wheels before you have to replace those liners. But again, what you're looking for is it's gonna wear down, and when you get to about 3/4 of the way through that, you want to replace your liners. On the dust collector, you want to be watching your suction meter up here. If you notice for some reason that you're dropping shot over here on the shot blaster, or if this isn't sucking correctly, then you may need to replace your filters. Another maintenance thing down here is to also watch your compressor. And at the end of every shift, there is a valve back here on the back side of the machine. You need to open that, especially in humid environments, and drain any condensation out of the machine, and also decompress the compressor. Thanks for joining me today. Obviously, there's a lot more that goes into these machines. If you've got any questions, don't hesitate to give us a call. Thanks again.